Hey everyone, ever wondered how passwords are kept safe and secure? Today, let's talk about hashing and how it keeps our passwords safe and secure. A strong password is essential for ensuring the safety of our online accounts and sensitive information. Storing passwords in plain text is highly insecure, as it exposes them to potential theft and exploitation. To enhance password security, we employ a technique called hashing, which transforms the password into an encrypted form. There are various hashing algorithms available, such as decrypted, hashlib, and many others. Among them, Argon 2 stands out as a top contender. Argon 2 is a cutting-edge password hashing function that emerged victorious in the password hashing competition of 2015. It boasts robust resistance against common cyber attacks, including dictionary attacks, brute force attacks, and pre-computation attacks. Now let's delve into the code. First, import the Argon 2 library, which provides functionality for hashing passwords using the Argon 2 algorithm. Next, define the password that we want to hash. Next, create a password hasher object. ph equals to argon2.passwordhasher. The line creates an instance of the password hasher class provided by the Argon 2 library. This object provides methods and attributes related to password hashing, such as hash, verify, and configuration options for the hashing process. Next, this is the heart of the process. Hash password equals to ph.hash and pass the password. Here we hash the password, using the hash method of the password hasher object ph. This method takes the password string as input and returns the hash password. Let's print it. Let's run the code. Here it is. This hash password can be securely stored in the database, and it's virtually impossible for any hacker to decrypt it. Now, let's see how to authenticate the password. Define an input password to verify with our hashed password. Next, a try except block to manage the verification process. We use a try except block here instead of an if-else block, because this password verification process raises a verify mismatch error exception if the input password does not match the stored hash password, rather than returning a simple Boolean false. Within the try block, we attempt to verify whether the hash version of the input password matches the stored hash password. ph.verify and pass the hash password and the input password. The verify method of the password hasher object compares the hashed password with the input password. If the verification succeeds, meaning the input password matches the hash password, and we print password verified successfully. If the verification fails due to a mismatch between the hash password and the input password, a verify mismatch error exception is raised, and the code jumps to the except block. There we print password verification failed. Let's run this code. Password verified successfully. Now let's give a wrong input password. Run the code. Password verification failed. That's a wrap, guys. This is how hashing a plaintext password operates. We understand the paramount importance of securing our passwords in today's digital age. Hashing algorithms like Argon 2 act as guardians, converting our passwords into fortified fortresses of cryptographic strength. In this ever-evolving realm of cybersecurity, the significance of robust hashing techniques cannot be overstated. They serve as the bedrock of our defense, standing as bulwarks against the relentless tide of cyber threats. Argon 2 stands as one of the most robust and reliable techniques available, ensuring our online safety in an increasingly interconnected world. If you found this video helpful, don't forget to like, share, and subscribe for more exciting content. Happy coding. Have a good day.